Alright, so we're going to keep on going and working on some more of these types of questions. Which graph represents the reflection in the x-axis of the curve y is equal to cosine of x? Okay, so we're not just looking for a graph of what cosine looks like. We're looking for cosine that has been reflected, so essentially flipped upside down. So the same thing is true for what I told you in the other question. If we're looking for a cosine curve, I can eliminate this one and this one because they both go through the origin, meaning those are sine curves. Get them out of the way right away. So we're left with two different options, this one and that one. Now, the difference that I see between them is if you're looking at the x or the y-axis right here, cosine typically looks like this, where you start at your max and then you go like that. So to me, because there's nothing labeled on the x-axis, I don't know how big this curve is supposed to be, but I do know that cosine is supposed to go through its max first and then come down to its minimum. But that's normal cosine. We're not looking for cosine, we're looking for the reflection of cosine, so everything would be upside down. So this one is going to be our answer because it starts at its minimum, ends at its minimum, goes through the max in between. That's the opposite of what it normally does, so this is our answer. Okay. Ooh, that looks like a bad picture, but okay. Which of the following shows the graph of the function -2 cosine x minus pi over 4? Okay, this question really is not fun. We did this in class. It's just not a good question. The reason why is because once they throw in horizontal shifts going left and right, it just throws everything all out of whack. But let's try it together. So number one, I can see that this is a cosine curve. So normally what I would say is go through and cross off all the ones that go through the origin, but because it's been shifted to the left or to the right, none of them are going to go through the origin anymore because now it's been shifted. So because this is minus pi over 4, that means that we've actually been shifted to the right pi over 4, or to the right 90 degrees. So what you can do is look at this graph and say, if this graph has been shifted to the right pi over 4, which is about like right here. See, this is pi. That's pi over 2. This must be pi over 4. So it got shifted. Then this point right here, it was originally, back before we got shifted, it was originally right there. Okay. And then you can say the same for this. This point was originally back right here. This point was originally here. This point was originally here. So then you can kind of go through and connect those dots and say, all right, that's what my picture looked like originally. I mean, ooh, that was bad, but you know what I'm saying. Okay, so what I can do is say that because everything got shifted to the right, what if we bring it to the back a little bit? It looks like this one would have been going right about like that. This wouldn't have been really centered on the axis. It would have kind of looked like this. This one got shifted, so it would look like this. So that's why questions like this are really, really difficult. So what I'm going to do is I'm going to look for the graph that, because it's cosine and it's a -2, meaning it's been flipped over, it starts at its minimum, ends at its minimum, goes through the max in between. I'm going to look for the graph that starts at a -2. And I can see that this one actually does start at a -2. The other way that you could approach problems like this is use your graphing calculator. You could actually type this whole thing in. So -2 cosine of x minus pi over 4. But no one in class liked these questions, so it was like really bad. And then I'm also going to set up my window to be between +2 and -2, -2 pi and +2 pi, just so that it's set up with the way that the pictures are. So between -2 pi and +2 pi, between -2y and +2y. And then let's graph. Okay. So that's what the picture looks like. So then you can kind of just go out and you know, cross off the ones that's definitely not, and then kind of eliminate other choices as you go. So I can see that this one clearly is not it because it doesn't have, you know, the hill going up there at +2. This one's clearly not it. and this one's not it because that valley ends to the left of the axis, whereas this picture ends to the right of the axis, so you can see it's right there. So this is your answer. That's also probably an easier way of doing it anyways. Okay, unfortunately I forgot your folder. I don't have it with me right now, so I don't know exactly what homework number it is, but whatever video I did yesterday, you know, it's the next homework assignment, and I can just always double check that for you. You also have them written out on the blue sheet, so whatever homework assignment that is, I think that you should be able to complete that without any problem now. Okay, now we're going to talk about graphing of the tangent function, as long as I have, yes, I have a lot of time. Graphing the tangent function. Okay, so far we know sine and cosine down pretty good. You should at this point be able to graph them. If I give you, a picture or an equation, you should be able to, pick out the equation if I give you a graph, all that fun stuff for sine and cosine. Now we're going to deal with tangent, just because it's a little bit different. Unlike the graphs of sine and cosine, tangent is not continuous. And why do you think that tangent is not continuous? And you could get that information by, looking at your unit circle or looking at your trig plate, either one. You remember how for tangent I told you that if you're looking at the values of tangent that were going across this line, so 0, 180, or 360, those values of tangent were equal to 0. And then if you were looking at tangent along this line, then those values of tangent were undefined. So at 90 and 270, tangent is undefined. And that's exactly why tangent is different than sine and cosine, because sine and cosine both are continuous curves. They just keep going on in, on for infinity in whatever direction. Tangent, on the other hand, is not continuous. The reason why is because it's undefined at every, 180 degrees. So you start up here and you go to 90, and then we're fine, and then it's undefined again. Then we're fine, it's undefined again. So there are these things that we're going to call asymptotes, and I'm going to show you what that means in 1 second. And it means that tangent is never ever going to touch those lines. It's going to get really close, but it's never going to touch them. So I think that what we did is kind of just broke up this graph into segments of pi over 4 all over again, and I can go through that with you. But I am going to do something quick and make the magic table so that I know what I'm doing, because I need to remember what tangent of 45 degrees is. So 30, 45, 60. I'm not going to make the sine and the cosine part, but if I'm only looking at tangent, then tangent of 30 is radical 3 over 3. 45 is 1, and this is radical 3. Okay. So, because I'm going to go in segments of 45 degrees, and all students take calculus. That's going to be helpful as well. Okay, so I'm going to go in segments of 45 degrees, or pi over 4. So pi over 4, that's 1 pi over 4. 2 pi over 4, which is pi over 2. 3 pi over 4. 4 pi over 4, which is just pi. 5 pi over 4. 6 pi over 4, which is the same thing as 3 pi over 2. 7 pi over 4. And 8 pi over 4, which is the same thing as 2 pi. I have an empty space, and that's probably because I missed 0. Whoops, my bad. Okay, so tangent of x, let's find out what the tangent of 0 is. 0 lies on this line that's going across like that, so the slope of that line is 0, so tangent of 0 is just 0. Tangent of 45, or pi over 4, is 1. Tangent of 90 is undefined. Tangent of the cousin of pi over 4, so now we're in the second quadrant, that's going to be -1. Tangent at pi is 0, because it's along this line. 5 pi over 4, that's the cousin, and we're down here in the third quadrant now, so that's going to be a +1. 3 pi over 2, that's 270 degrees. We are undefined again. 7 pi over 4, now we're in this quadrant, the cousin of 45 degrees, it's going to be a -1, and then 2 pi is the same thing as 0, which is 0. Okay, so let's go through and graph this. Okay, so I'm going to put arrows on my axes. I'm going to label everything correctly. So my x. Okay. Then I'm going to jump by pi over 4 radians. It's unfortunate that I have to write this whole thing out every single time. Oh well. Okay. Now I'm going to do this in different colors so that we can see it easier. So at 0, tangent is equal to 0. Pi over 4, tangent is equal to 1. We'll make that there, and we'll make this here. Tangent is equal to 1 right here. And at pi over 2, tangent's undefined. So what I'm going to do, whenever it's undefined, I'm going to draw this vertical line. It's called an asymptote, and it means that, you know, tangent is never going to touch that line right there. Okay, now let's just keep going. At 3 pi over 4, we're at -1, which is right here. At pi, we're at 0. 5 pi over 4, we're at +1. 3 pi over 2 is undefined again, so I'm going to go back and make another vertical line. It's called an asymptote, and it can never ever touch that line. And 7 pi over 4, we're at -1 again, and at 2 pi, we're at 0. This is what the graph of tangent looks like. And it's going to get really close to that line but never touch it. And then it's going to come down. It's going to be really, really close to that line, never touch it, go through these points, and then come back up again. It's going to do the same thing right here. And then it would keep continuing. So what tangent looks like is just like a bunch of like waves. And those vertical lines are called asymptotes. It's where something can, the function is never ever going to touch. So let me show you what this looks like on a graph really quickly. I'm going to change that from 0 to 2 pi. Actually, I can leave it like this. That's fine. Whatever. Well, let's just graph what tangent of x looks like. Graph. Okay. So you can see how it's just like a bunch of curves, and it's not continuous because it's broken up into a bunch of different sections, okay? So that's what tangent looks like, and you could check that out on your calculator if you have it in front of you. What is the period of the tangent curve? The period is the length of the interval needed to see one full curve, and the period is pi. It takes pi radians to see one full curve, except for the fact that, like if you look right here, it doesn't go from 0 to pi to 2 pi. It actually goes from -pi over 2 to +pi over 2, and then from +pi over 2 to 3 pi over 2, 3 pi over 2 to, I don't know, 7 pi, I don't know, something like that. So it doesn't really go from 0 to pi, but pi is the length of the interval needed to see one full curve. Okay? What is the amplitude of the tangent curve? The amplitude of the tangent curve is all real numbers, or infinity, or something. The tangent curve goes on and extends off to positive infinity up and negative infinity going down. So it doesn't really have an amplitude. It's all real numbers or infinity, something like that. Okay?